Hi, today we're going to be going over our BMS demo from DSpace. So here we have a small BMS rack. This is a scaled down version of our bigger customized BMS systems, but we still have all of the same components in here to show you today. So starting on the bottom, we have our Subrack, and this holds our cell simulation boards. So each board in this demo has 2 cells that are being simulated on it, and then we can fill the Subrack to increase the number of cells in the battery pack, as well as stack multiple Subracks together depending on how big your battery pack is. We have other boards that we can fit in this Subrack as well for different number of channels or temperature simulation. So there's a lot of options, and it's very configurable for your application. And inside this safety compartment, we also have our BMS that is connected to our tablet here, where we're monitoring the cell voltages and everything the BMS is measuring. So we have a harness connected to the cells. We also have a harness connected to our temperature simulation as well. And then up here we have our low voltage power supply and a high voltage power supply. So those are representing different voltage levels and buses that you might have in your application for your BMS. And we can put together however many power supplies you need. If you have a power supply for the pre-charge circuit or maybe the whole cell stack, a lot of options and very configurable to your needs. We also have behind this panel a processor board that's running our battery model and has various low voltage I/O to control different components of the system or any low voltage I/O that you might have for your BMS. So maybe a bus channel or other options that you might need simulated. And then we come to our safety features. We have independent control over the power for the whole system, as well as just the high voltage components. And then we also have an isolation monitor for each high voltage component of the system. So we're measuring the isolation between the high voltage point in the system in comparison to the chassis. So that way, if the isolation breaks down, we can shut off the system before the chassis gets shorted to high voltage in the system, and then it becomes dangerous in the lab. We also have a safety compartment here. So if this door is opened while the high voltage is on, then we can cut off all of the high voltage to the system. So then everything becomes safe to touch inside the safety compartment if you need to adjust a harness or switch out your BMS or anything of that nature. We have an emergency stop as well, and we have lights indicating the state of the BMS system. So right now everything is powered on, and that's yellow and green. So now when we move over to here, we have our control desk interface. So this is interfacing with the processor board on the system that is running the ASM battery model, as well as controlling the different components of the system. So here we can see we have 6 cells that are being simulated. Our battery model is controlling the state of charge of the 6 cells, as well as monitoring the current for any cell balancing that the BMS might want to do. And then we also have control over different scenarios of the system. So we can simulate a charging scenario. And as we see the cells creep over 90% state of charge, then our BMS here starts balancing current between multiple cells. So you can see the current increasing for a couple of the channels as we're draining capacity there in order to get the state of charge for the different cells to be equal. And then here we can simulate a driving scenario. So all the cells are being drained. You can see that there's 10 amps coming out of the battery pack in total. And then as some of the cells are above 90% and others are below, again, our BMS is going to start cell balancing for that. All of these different scenarios, they are user configurable. So you can simulate different fault scenarios or different driving scenarios depending on what you're trying to test for your BMS. And then now if we take a closer look at the battery model, These are all different points that are coming out of the Simulink model. So we have inductance, double layer, diffusion, any losses and current in the system. So these are all components that you can configure in Simulink. You can run in Control Desk. You can automate these different scenarios. Everything is very open, and so this battery model provides a really good starting point for you to represent your battery in software and get all of those different testing scenarios handled by your BMS test system. Yeah, that's everything that we have today. Thanks for listening.
DSpace, your partner in simulation and validation.